So here we go. We want to graph the functions y equals 1 over x squared and y equals 1 over x minus 2 squared plus 1. And we want to compare the characteristics of these graphs. So you guys will notice if you look at your graphing calculator, I already have a rough sketch of y equals 1 over x squared included right here. It's pretty much the exact same thing as y equals 1 over x. The only big thing that you'll notice is this piece right here has jumped above the x-axis as opposed to below it. And the reason why is because that x squared is always positive. So since that x squared is always positive, by putting 1 over a positive number, it's still going to be a positive number. Scrolling down here, my vertical asymptote on this, well, we see it remains at x equals 0. As well, my horizontal asymptote is going to be at y equals 0. Now, for my x and my y-intercept, if we scroll up and look at this, we'll notice something interesting. It doesn't actually cross the x-axis because there's an asymptote there, and it doesn't cross the y-axis because there's an asymptote there. So we're just going to say that it doesn't have an x-intercept, nor does it have a y-intercept. My domain, I can be any value for x with the exception of x equals 0. So we just go curly bracket x where x cannot equal 0 and x is in the set of real numbers. My range is a bit more complicated. We notice that I can't occupy this bottom part of the graph or anything under the x-axis, nor can I be on the x-axis. So my range is just going to be y, where y is greater than 0 and y is in the set of real numbers. Now, looking at y equals 1 over x minus 2 squared plus 1. The first thing that we'll look at is that vertical asymptote. My vertical asymptote, because I have that x minus 2, is going to shift 2 units to the right. So my vertical asymptote is now going to be at x equals 2. My horizontal asymptote, because I have that plus 1, it shifts 1 unit upwards. So I'm just going to quickly draw that in right there. And we can see that that's going to be y equals 1. Now, just to remove some of the clutter from this graph, I'm just going to erase that y equals 1 over x squared graph that I had in there. So it's a bit more clear what's going on here. My characteristics, my x-intercept and my y-intercept. Well, if we look up at this graph, we'll notice that there's no x-intercept because I've just shifted that original graph upwards. Originally there was no x-intercept, so if I shift it upwards, there's still not going to be one. But just for funsies, let's see what happens if we try to find the x-intercept. So what we have right here is I'm looking for my x-intercept, and we know that y equals 0. So I get 0 equals 1 over x minus 2 squared plus 1. I move the 1 over to the other side, and I get negative 1 equals 1 all over x minus 2 squared. I multiply both sides by that x minus 2 squared, and I get negative x minus 2 squared equals 1. Well, I multiply that negative 1 by both sides, and I get x minus 2 squared equals negative 1. I take the square root of both sides, and I get x minus 2 equals the square root of negative 1. Now, some of you guys that are a bit more savvy may realize that, well, the square root of negative 1 is equal to I, and I is the symbol that we use for an imaginary number. But even though we have a letter and we call it an imaginary number, in the real number system, we still say it doesn't exist. So for my x-intercept, I'm just going to say, well, I don't have one. My y-intercept, well, let's check this out. For my y-intercept, I know that x is equal to 0. So I get y equals 1 all over 0 minus 2 squared plus 1. y equals 1 over 4 plus 1, or y will equal 5 over 4, which is also equivalent to 1.25. So my y-intercept is going to occur right about there at 1.25. I scroll down here, my y-intercept is going to be at y equals 1.25. Now, drawing in my rough sketch of this, I curve, I go off like that, and again, I'm going to look very similar to the graph that I originally had on there. I apologize I went up a bit right there, but you guys know better. From here, my domain. Well, my domain, the value, or rather my vertical asymptote, shifted 2 units to the right. So my domain is now just going to be x, where x cannot equal 2, and x is in the set of real numbers. My range, my horizontal asymptote shifted 1 unit upwards. Thus, it's going to be y, where y is greater than 1, and y is in the set of real numbers. And for you guys that are a bit keen, you'll notice that I drew an extra comma in there, which I'm just going to delete. But with that, we have compared these two graphs.